Is the Smart Buildings Academy podcast with Phil Zito, episode 383. Hey folks, Phil Zito here, and welcome to episode 383 of the Smart Buildings Academy podcast. In this episode, we are going to be looking at another ASHRAE standard. We are going to be looking at 62.1, which is the commercial version of the indoor air quality specification standard. As always, everything will be available at the link in the description below. So feel free to go and check our resources out after this. I do want to take a second real quickly to point out a couple things. First off, thank you very much to Andrew of the DDC who left us a 5-star review on iTunes, talking about if you are in the controls industry in any way, you have to follow Smart Buildings Academy on these podcasts. If you are in HVAC, you need to follow this too. If you need to learn the fundamentals or stay on the cutting edge, this is the way. I don't know if it was intentional, but I like the little Mandalorian quote there at the end. And thank you so much, Andrew, for that review. Definitely appreciate it. All right. The other thing I want to talk to you about, just a heads up. So a lot of folks have reached out about our workforce development program. You know, it's unheard of to take people who have no field experience and turn them into startup technicians in 11 weeks. But we've done it not once, not twice, but 3 times now, with 3 separate cohorts having gone through this program. And cohort 4 is open for enrollment right now. It starts January 9th. So if you find yourself going, man, we're using programmers to do startup tasks, or we do not have the people we need to execute backlog, and if this summer repeats itself, it's going to be a crap show because we barely could staff up jobs as it was, then you definitely need to learn more about our workforce development program. Feel free to hit us up in the chat. I can send you information about that. Reach out to us on our website, smartbuildingsacademy.com. Or go and contact me directly, LinkedIn, YouTube, Facebook, and I can get you more information. That program is filling up, and definitely if that is something you want to do, if you have a desire to staff up quickly and you want your staff to be able to go from knowing nothing to being able to go and line out electricians, install controls, wire them up, connect them to the network, upload and download programs, then you definitely need to check out our workforce development program. All right, that being said, so ASHRAE 90.1, I wasn't really sure how that podcast was going to go. I was like, are people actually going to enjoy me reading a ASHRAE standard to them? Surprisingly, it was one of our most listened to podcasts on first day listens. I was really shocked by that, which shows there's a real hunger for understanding these ASHRAE standards. And so today, ladies and gentlemen, we are going to be diving into ASHRAE 62.1, affectionately known as the Ventilation and Acceptable Indoor Air Quality Standard. Now, this standard has been updated as of 2022, so it supersedes the 2019 standard. This one is a lot easier to digest. It's very simple and straightforward, and it's really cool at the same time. There's a lot of neat changes that came about as part of the standard. So for those of you who you've not read the standard yet, we're going to be going through it in great detail. And for those of you who wonder, how does this apply to either my building or to my controls work, stand by because we're going to go through it all. As always, the standard starts with the purpose, scope, and definitions, which is pretty general for an ASHRAE standard. And so the purpose, quite simply, of this standard is to specify the minimum ventilation rates and other measures intended to provide indoor air quality that is acceptable to human occupants and minimizes adverse health effects. So this is for new buildings, additions to existing buildings, and changes to existing buildings. Very similar to the scope of 90.1 as far as what buildings it applies to. So the scope talks about, it is applied to spaces that are intended for human occupancy. And it talks about the requirements of air cleaning, ventilation, installation, commissioning, and operations and maintenance. And it also talks about how this goes and has requirements on the prescriptive side, right? Related to certain contaminants, sources, outdoor air, construction processes, moisture, mold, etc. There's a lot of really cool stuff that we're going to see in this episode that has to do with the three major types of indoor air quality performance, which is going to be known quite simply as the ventilation rate procedures, the indoor air quality procedure, or the natural ventilation procedure. Those are our three procedures of which we're really going to focus in on. So if we go ahead, and by the way, this is a one where don't skip definitions. They have some really, ASHRAE always does an amazing job of doing definitions in their standards. They do really good definitions, but they also in figure 3.1 have a really good graphic of a ventilation system, which if you've never seen ventilation systems before and you have no idea what this looks like, then definitely go and check that out, because that graphic is going to make things, just that much more clear to you as you go through understanding what they're talking about in the standard. Now, in outdoor air quality, which is section 4, they talk about, which, by the way, I really like that this is in here, because I've got a lot of horror stories around outdoor air quality and occupant health. I can think of one where a gentleman was working in a pretty unoccupied area, and he kept getting sick. No one could figure it out. It turned out that the outdoor air intake, which used to be in a fine spot, actually was now located near a loading dock because they reconfigured the outside of the building. And so every time these vehicles were sitting there, they would go and carbon monoxide, right, would come into the outdoor air intake. Person would get tired, wouldn't feel good, would be sick. But anytime you go to kind of run a test, you weren't catching it. And it wasn't until one day when someone was doing maintenance that they discovered this was going on, dealt with the issue, and that person almost immediately started feeling better. It's kind of crazy how fast health can change due to air quality. So it's really cool that they spend time on this. It is a little bit short, but they do talk about how do you do the observational survey of local air quality. And the important part of this is to determine, do I need to do any air cleaning, any air treatment prior to ingesting this outdoor air into the building, either through the VRP, the IAQP, or the NVP methods, those being the ventilation rate procedure, indoor air quality procedure, or natural ventilation procedure methodologies. Section number 5 is a lot to take in. It does go through a lot of details, some of which we're going to skip over, but it is a good read nonetheless. Talks about building envelope and interior surfaces, things like condensation, because what does condensation do? It produces mold, right? There's a focus in here as well on humidity, which we'll talk about a little bit later. Talks about parking garages and having appropriate ventilation, basically having appropriate pressure, positive pressure to push out whatever is going on in the garage so that it doesn't come into the occupant space. Talks about, excuse me, different areas of the space and how do we separate them? How do we keep the air clean? How do we classify it? What do we do with our outdoor air intakes, our exhaust, any fuel burning equipment, all of that jazz. I'm going to skip forward, however, to right here, which is something that is pertinent to a lot of people. And I realize you can't see this because, unfortunately, due to the copyright, I can't go and share this on screen. But 5.9 ozone generating devices. This is really interesting because ozone generation devices, what are we thinking of? Maybe GPON, right? So our GPON, not GPON, oh my gosh, passive ionization, GPON, oh my gosh. That's gigabit passive optical networks. That's a way of distributing networking in an OT environment. I don't know why I thought about that. But no, we're talking about passive ionization, things like that. We're talking, so, needlepoint passive ionization. Things like UV lights, some of those that may cause a chemical reaction that produces ozone. And it has a neat little thing about that, kind of says what they need to really be concerned about. So it gives you some spec stuff. It talks about air balancing. It talks about airstream surfaces. And then it gets into this neat little thing right here called 5.12, which is mechanically or indirectly evaporatively cooled buildings. Basically, what they say is keep the dew point, right? You have to limit the indoor humidity to a maximum dew point of 60 degrees Fahrenheit. Essentially, we don't want to create condensate. We don't want to start to create all this moisture. So that's a really important thing for us to focus in on. I'm going to skip through exfiltration of the building, and we're going to go to right here, which is procedures. This is where everyone kind of tends to gravitate because they want to know, what do I have to do? Like, what do I have to do to actually go and implement ASHRAE 62.1? I'm going to caution this with, I am not an expert on 62.1. I did not author the standard. So validate this with someone who is an expert. We're learning this together. I have implemented a lot of demand control ventilation in the past. I have sized minimum outdoor air per the ASHRAE 62.1 requirements for spaces. So I understand how all this works. But if I say something wrong and you're an expert on this, feel free to correct me. This is more of an education for all of us in the industry. With that little commercial out of the way, let's dive in. The ventilation rate procedure is the first one we're going to focus on. This is prescriptive. So there's a difference, right, between performance and prescriptive in our ASHRAE standards. Remember, prescriptive is this is what it shall be. These are the standards that it shall adhere to. Whereas performance is this is where we're looking to get to. They still have metrics on both of these procedures, but in the prescriptive, we define it up front. On the performance, we define a system that should be able to perform to these metrics. All right. That being said, let's continue right along. All right. I'm just going to pull this over here so I can see any chat that comes from you all. Okay. Ventilation rate procedure. Let's talk about this bad boy right here. Let me open this guy up. 6.2. So essentially, we need to determine our outdoor air intake flow, which they're going to call some sort of algorithmic symbol. Then we have to determine it in accordance with section 6.14, 6.2.1, and 6.2.6. Now, there's this equation. Like I said, we don't do equations on the podcast. It's really hard to communicate equations. But essentially, you take a bunch of factors into play, and based on square footage, based on population, based on space type, you're going to calculate what is known as your minimum outdoor ventilation flow. So this is what you need to serve into the zones and through the system. What we typically will do is we will calculate our zones, and then our zones add up to our zone distributing system, and that gives us kind of what we need to do. How this really typically happens is we just look at a percentage, and that sizes the percentage. Sometimes we will get more accurate, and we'll actually use outside airflow monitoring, and we will have an amount that we need to measure and provide. So for example, I'll just pick a random thing here. No, we're not going to do that. Art classroom for educational facilities. And if I look at this, it says people outdoor air rate, area outdoor air rate, default values, air class, etc. So if I look at the art classroom, it says 10 CFM per person. It's a little bit on the higher side because obviously the chemicals that are going to be in the space. And then we see CFM per square feet. And by the way, folks, they have this in meters per person, just so you know. So it's not just imperial, it's also metric. But in this case, it's 0.18 CFM per person for this area. And then they have default occupancy density. So 20 people typically fill an art classroom. So that is, so you'd say, okay, I've got 1,000 square feet. Then if I do my math right, you would need 18 CFM of outdoor air. Let's use the handy dandy calculator real quick, because you all know I am not the greatest with math on the fly. 180 outdoor air CFM for that art classroom. And if you had multiple art classrooms, right, you can start to figure out how much of that air needs to be outdoor air. And then you can start to appropriately size your unit at the air handler level. All right, let's skip forward and let's get into a couple things here. Unlisted occupancy, where occupancy is not listed, you want to grab a similar term based on activity or building construction type. One of the things that they talk about here is they talk about air density. So they're assuming a certain amount of air density. So basically this shall change based on where you're at elevation wise, essentially is what it's saying. And then they talk about, little things like animal facilities, laboratories, dwelling. But where I really want us to focus in on, let me go down here, is to the zone area distribution effectiveness. This is an area of consternation for a lot of people due to stratification of airstreams. So what stratification is essentially like maybe you bring a return air and you have an outdoor airstream and they're mixing. And what happens is that airstream, it mixes, and cold and hot air, they don't mix properly, which could potentially give you an issue. That's why they call out things like what your supply air should be at, and it's tied to room temperature. They talk about where your return air opening should be, and they talk about things that essentially affect the mixing of the air. They talk a little bit about personalized ventilation systems, but I haven't really seen that in effect. I've seen organizations try to introduce them, but I've also seen them removed. They give equations for zone outdoor airflow, single zone systems, 100% air systems, multi-zone systems. I'm not going to go and read those out to you. You can read them yourself, but it's pretty straightforward. They talk about occupant diversity. So what type of occupants do you have? What are you using things for? They do have a simplified procedure. Like most ASHRAE standards, they have a simplified procedure where they have a simple equation for you to use. And that simplified procedure has zone minimums, outdoor air intake percentages, etc. Now we're going to get into what everyone's kind of hot to trot about, and this has been around for a long time, which is this design for varying operating conditions. So we're talking like things that are partial load. Think like an auditorium, cafeteria, etc. This is where we can start to do what pops up in 6.2.6, which is dynamic reset. And this is demand controlled ventilation. So demand control ventilation essentially is CO2 driven. CO2 is what we breathe out when we respirate. And so an increase in CO2 against baseline is going to go and indicate that the fresh air density is not up to snuff. And thus, we need to open up the outdoor air damper more. Now, the nice thing about this is that you don't have to open up your outdoor air damper if your CO2 is being maintained. And what that does is that reduces energy consumption in the form of heating and cooling to condition outdoor air that otherwise may not have needed to be conditioned. They do talk about accuracy of sensors, 75 parts per million at concentrations of 600 and 1,000. They talk about temperatures, factory calibration of the sensors, etc. It's a good read. I highly encourage you to either check out the read-only version or to go purchase the standard. Like, quite frankly, if you're serious about this industry, like you're really serious, ASHRAE 55, ASHRAE 62.1, ASHRAE 90.1, you should definitely purchase those standards. They're only a couple $100. I know that seems like a lot, but this is stuff that is directly applicable to our trade as building professionals. And I'm not sponsored to say that or anything, just to be clear. It's just something I believe we should do because it helps fund these standards, as well as it's good to have them because you can mark them up, sticky and note them and all that jazz. It talks about how do we do DCV, how do we document it, how do we go and measure things. Now we're going to move to the next procedure, which is called indoor air quality procedure. So this is an interesting one. This is where we start to actually look at VOCs and DCs, which are design compounds. So primarily we focus on what are called DCs from a DC list, and PM, which is particulate matter 2.5 microns. 2.5, if I remember correctly, this is the level of micron that can penetrate the lung layer, get into the alveoli, whatever they're called, alveoli, something like that, and get into your bloodstream and potentially poison you over time. So they give an equation here that you are trying to maintain to. And essentially you design your zone and outdoor airflow rates so that you can go and effectively deal with the emission rates, concentration limits, and other design parameters. So this is going to be a performance specification versus a prescriptive, because you are performing, you are trying to meet these performance requirements. So this is something where you would look at the space and either through a PM or VOC meter, you would go and try to adhere to this. There's also this thing of perceived indoor air quality that gets factored in, which can be done by voting. People vote using an app or survey that they are perceiving a certain air quality as good or bad. And then based on that, you need to increase your ventilation. You see this sometimes in the conference environment, so conference spaces. All right, speaking of indoor air quality, as I'm coughing because of the lack of humidity, combined indoor air quality procedure and ventilation rate procedure. You can combine the two, right? You can combine the IAQP and the VRP and use them to go and dynamically adjust the outdoor airflow that's required for specific zones. You see this in the production environments where chemicals are typically being used. And while CO2 and occupant airflow may not be as good a measure as the particulate matter or the volatile chemicals that are within a production space of maybe a lab or like a painting area or something like that. So you may have to implement the temporary ventilation aspect of IAQP to raise it up. VRP. you would go and raise up your ventilation threshold for the VRP, for the ventilation rate procedure. And then finally, there's natural ventilation procedure. This is where folks, there's so much to this. Indoor air barriers, so air curtains, ventilated spaces. Basically, if you're able to go and use natural ventilation, windows and doors, this is like West Coast, where the humidity is such that you can go and actually use, and the temperature is such that you can use natural ventilation. So that is something to consider. It's not so common across the board that I would use it as my primary. Obviously, you're not going to use it as your primary in the majority of cases. They talk about the prescriptive compliance path for NVP, natural ventilation procedure, which is essentially going and making sure that you have certain ventilation requirements around square footage, around ceiling height, opening types of doors, size of openings, locations of openings, etc. A lot of math here, a lot of design, not going to dive too terribly into it. And then finally, they do exhaust ventilation, which there is a prescriptive path to this. It talks about pressure requirements for this, and there is a performance path as well. So the prescriptive path is going to be thou shalt hit these pressures for these space types, and the performance path is based on certain contaminant types and contaminant concentrations. Obviously, you're going to have to monitor these concentrations. It reminds me of I did a battery bank at a data center, and what were we measuring for? Holy crap, I can't remember. It was an odd VOC or an odd DC. I can't remember what it was. Wasn't nitrogen. It obviously wasn't CO2, and it wasn't I don't remember. It'll come back to me maybe. Then it goes into construction and startup, which, is something that I've seen personally. Startup and construction have a dramatic effect on indoor air quality. The building envelope isn't complete yet. People are just no filters in, and they're sucking this air with all this particulate matter, and it's clogging coils and getting all in the ducts. We really want to try to protect from that. So they dive in 7.2 into proper system startup with air balancing, with protecting our dampers, protecting our air quality, and how do we actually test our air quality. And they go through a bunch of test methods to do that. And those are in tables 7.1 through 7.3. Finally, we have our design compounds and PM measurement test that is done during startup. Remember that this is tied to our indoor air quality procedure. So this is where we are going to look to see, are we hitting these standards from a performance perspective? And if not, we need to go and take effect. And then finally, there's operations and maintenance, where all of this falls apart, right? Everyone's building works great until it doesn't work great. And this is why I'm a strong advocate of good, solid as-built, good owner training, and proper operational procedures. So here in the operations and maintenance, they talk about building alterations and change of use. How do you document and deal with that? How does your operations and manual work? And then how do you build out your ventilation system operation and maintenance strategy? They actually provide in table 8.1. So if you're on the service side or you're a building owner and you're like, how do I do? What do I do? They actually have an inspection and maintenance task list with frequency that you can refer to. And this is pretty detailed. So it's a really good list. If you're not aware of it, you definitely should be aware of it. Especially those of you who are on the service side. You're like, what can I provide as part of a service to my customers? Well, I mean, it's literally right here for you. So definitely take advantage of that. And then, as always, they have a really good Section 9 normative references where they reference a ton of different standards that you can then later find and point to. So, this is really helpful as well. And as always, they have a bunch of informative appendixes that you can go and read through. And then they have what I like is the informative appendix H, which is application, which is how do we actually apply this to different buildings? Like, how do we apply it? And then how do we comply to it? So it's all right here in ASHRAE 62.1. Definitely encourage you to check out those standards, or this standard. I'll pause to see whatever questions you have. Hopefully this has been beneficial to you and you've been able to take some information from this and you found this to be a useful podcast for you. So I'll see what you got to say, whatever questions I can answer. As always, everything's available at our podcast site at podcast.smartbuildingsacademy.com/383. Once again, that's podcast.smartbuildingsacademy.com/383. You'll be able to find anything I mentioned there from a link perspective. And if you are finding this valuable, then do what Andrew did. Leave us a 5-star review on iTunes. Like, subscribe, and hit the notification bell on YouTube, or comment and or share this on LinkedIn. My hope is to get through ASHRAE 55 next week, probably standard 202 as well, and give you my perspective as we learn these standards together. ASHRAE's done a lot of great work on this, and definitely want you to be able to appreciate what is in the standard. All right. I'll see if there's any questions, but other than that, that's all we got for ASHRAE 55, 62.1. So we'll see if anyone has any questions. Let me check the regular spots. I'll go to YouTube, see if anything is there, and nothing there, so we're good. And not seeing anything on LinkedIn or Facebook. All right, super easy. Thanks so much, folks, for listening today. We've got a good guest interview coming up on Friday that I think you will enjoy. It's all around space design and space utilization strategies. So I think you will, or use case design and use case utilization strategies, sorry. So I think you'll find that interesting. Thanks so much for being here, everybody, and I will talk to you all on Friday. Have a great day and take care.